All right, in this video, we want to solve this kind of word problem over here. Not exactly a word problem, but it's basically kind of like a combination of two different functions. It's more of a practical question. So let's take a look at it and see how to solve it. It says Rod says that he's thinking of two functions that have the following characteristics. One is rational and has a y-intercept of -2. One is trigonometric, does not include the cosine function. One contains the digit 3 and the other does not. Both have instantaneous rates of change of 1.23, rounded to two decimal places at x equals 2. And the two functions intersect at x equals to 2 as well. Provide one example of the pair of functions that meets Rod's criteria. Explain your thought process in making the function. Screenshot and calculations to verify each criteria. So the good thing in this question is we can use Desmos for this question, because if you were doing it on paper, it would probably take about like 2 hours to do this on paper, maybe even more, honestly. You're not using online calculators, but Desmos is great for this because you can do this quite quick in Desmos. So you want to go to Google and you want to type in IROC Desmos. This is really important because using this function in Desmos is going to make it a lot quicker and easier to do this problem. So just click that first link there in Google. And as you can see, it sets up the whole IROC over here. By default, the point was already selected x equals to 2, which was the same as the question we had. Now bring up the question over here as well on the side so we can see it as well in Desmos 2. It's going to probably disappear as soon as I click in Desmos as well, but I'll keep bringing it up so that you can see it. But like it said, it tells us to do it at x equals to 2, the IROC, and over here the point is already selected as an x value of 2. But if you had to have a different x value, you could just change the x values over here and play around with these settings as well to change it. Now, the first thing you want to do is you just want to change this h value to 0.001, because we want to have an interval of 0.001, which is great for an IROC. So now you can see the IROC for this default function on Desmos over here, and it automatically calculates the slope of the IROC, which is 2.001 at this point over here. Now, let's look at the question again. The first thing we want to do is a rational function that has a y-intercept of -2. So let's just make a regular rational function over here, which is just 1 over x. We got a rational function over here. The y-intercept is not accurate. It should be 2. There's no y-intercept here. And the other condition for this one was that the instantaneous rate of change at x equals to 2 has to be positive 1.23. So now if I look at this over here, I can shift this function to the left. So let's zoom into this. There's 2 right there. It's at -0.5. So I can just shift this minus 0.5. So as you can see, I just shifted the function to the left. So now I have a y-intercept of -2. You've satisfied that first condition. But if you look at the IROC here, my IROC is negative, which is not great because the first thing I want to do is make my IROC positive over here. So in order to make my IROC positive over here, I have to make this a reflection in the x-axis because that's the only way it's going to work. So now my IROC is positive, but my x-intercept has switched to +2. So what I'm going to do next is I'm just going to move this entire graph down by 4 units, -4. And as you can see over here, now my y-intercept is -2. My IROC is positive, it's 0.444. As you can see in the question, we need to get it to 1.23, positive 1.23. So I'm positive right now. I just want to get it closer to this point over here. So all you want to do is kind of play around with the numbers a bit. The next thing I'll do is I'm just going to change this -1 to a -2. Let's see how it affects the slope. Well, that's getting closer to 1.23. 1.23. But my y-intercept has changed, so I need to move it down another 2 units. I'm going to change this to minus 6. I'm a bit closer now, but obviously I'm not the right solution yet. So if you notice, when I change this from -4 to -6, the slope didn't change at all, because moving the graph up or down does not change the IROC at a specific X value. So I'm just going to play around with this value on top here and figure out the right IROC over here. So let's go 2.5, getting closer to 1.23. Let's go 2.6, it's even closer, 2.7. 2.8 is a bit too high, so 2.75. That's pretty close. I mean, that's pretty much accurate if I round it. So I can do negative 2.76, 2.77, even more accurate. It's almost exactly 1.23. And then one more thing I can do over here is, if I look back at the question, it says one contains the digit 3 and the other does not. So if I just make this 2.773, if I round this to 2 decimal places, I'm still at 1.23. And now I've taken care of this extra criteria in the C part. So I've got my rational function. It has a y-intercept of -2. It has an IROC of 1.23 at x equals to 2. And I included this first part of part C, which means the other function, the trigonometric function in part B, will not have a 3 in that function. And we don't have to worry about this last one for now, because once we get to the last part right there, we'll kind of get to that. But first, let's do the individual functions. So we've got the first rational function right over here. Next, what I'm going to do is I'm going to create the trigonometric function. So again, I'll just go to IROC Desmos, instantaneous rate of change. I'll pick a tan function. You can pick tan or sine, but I'll pick a tan function because tan function has nice slopes over here. And I know it's positive slope, so pretty easy to do it like this. Again, start by changing your h to 0.001. The default for the x value is 2, which is good. If you look at the slope here, it's 5.76. 5.76 is too big. I want it to be 1.23 as well. So I'm going to shift this tan function a bit to the left. So let's shift it 1 unit to the left. If I shift it 1 unit to the left, as you can see, my slope was way too small, 1.029. So I'm going to increase this or decrease it. It doesn't really matter, because in a tan function, you have two possibilities, over there or over here. So let's make this 1.5 and see if we get closer. We did get closer. Let's make it a bit bigger, 1.6. And we just went a bit too much. So we know that it's between 1.5 and 1.6. I'll do 1.58 because we were a lot closer there. Still a bit too small. Let's make this tan 1.59. And there we go. We've got the second function now. So we've got our two functions over here that satisfy the first four conditions. So the rational one has a y-intercept of -2. The trigonometric one does not include the cosine function. The rational one has a 3, but the trigonometric one does not. Both have the same IROC. And now we just have to satisfy this last condition over here. So now to satisfy this last condition over here, I'm just going to open Desmos. I'm going to copy the first function. I'm going to copy the second function. Now remember, I can't move this first function up or down because that will change the y-intercept. But I can move this second function. I can move it up or down. So I want to make these 2 points the exact same. So this is 2 and 0.48 approximately. And this is 2 and negative 7.85. So you just have to do 0.48 minus negative 0.75. I'll do that on my calculator. Oh, sorry, 7.5. What am I saying? Let me check those points again. 0.48 and 7.85. Okay, so I'm going to start by moving this down. Although I feel like something's not right here. Did I forget to do something? -6. Oh, I forgot to make my y-intercept correct over here. So my y-intercept is, I have to move it down a bit more to get to -2. So let's change this to -7. It's almost there. 7.5. Almost there. 7.546. Now see, the y-intercept is 0 and -2. So I forgot to do that last little step there for the first function. Make sure you do that. So now I have my first function, my second function, my y-intercept for my first function is -2. And now I want to make these two functions intersect over here. So this is still 0.48, and this is -9.4 approximately, or -9.39. I'm going to subtract those two values. And if I do that, I get 9.87. So I can only move the tan function down, because if I move the rational function down, my y-intercept will no longer be at -2. So I'm going to move the tan function down -9.87 units. And now you can see that we satisfied all the conditions. If you want to zoom in, you can even zoom in, see if you can get even closer, but I think this is good enough. You can do extra decimal places if the question required. But now we have satisfied every single condition in this question over here. First function is rational, has a y-intercept of -2 right there. Second function is trig. It's a tan function, so it doesn't include a cosine function. First function has the digit 3 right there. The other one, second one, does not have a 3 anywhere. Both have an IROC of 1.23. I showed you that in the other Desmos. Then both functions intersect at x equals to 2. So you can put these two functions down as the pair of functions that meets Rod's criteria. Explain your thought process. You can state your thought process on how I just showed it in Desmos. A screenshot, you can take a screenshot of this in Desmos over here. If you want to highlight, you can highlight this point. Make sure you just round it. You can do that manually in like Paint or some other editing software. And then you can also show the y-intercept right there. And then calculations to verify, you can calculate the IROC for the two functions using your regular IROC calculations on paper. I'm not going to do that in this video because calculating IROC should be extremely simple if you're doing a question this complicated. So just do the IROC for the first function, do the IROC for the second function at x equals to 2. You should get the same IROC of 1.23 for both. And that basically answers this entire question. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.